Hello everyone, this is the video lecture for College Algebra Math 1414 Section 3.2 Polynomials. I think I spelled it right. Nomials. So, polynomials. Let's talk about polynomials. The way to know if you have like f of x equals something or other and if it's a polynomial or not, because they're going to ask, is that they have all the terms have positive integer powers. Positive integer powers. Let me give you some examples. So let's say that I have 3, 2, 1. And they say f of x is equal to 7x squared plus 5x cubed. They're going to say, is this a polynomial? And you're going to say, yes, because look at the powers. Are those positive integers? Yes. All right, good. If it's a polynomial, they're going to ask, hey, what's its degree? What they're meaning is the highest power. The highest power. And so you're going to say 3, because that's the biggest number in the power. Cool. 3, 2, 5. So what if we have f of x is equal to 7x to the 5th plus 5x cubed plus 2 over x? Is that a polynomial? And you're going to say, no. Why is that? Because this guy right here, technically, is 2x to the negative 1. Is that a positive integer? No. So I don't care if those are great, but any one of them that messes it up, the whole thing is messed up. So there you go. And there's no degree, so you don't have to talk about that. All right. How do we know if a graph is a polynomial? So I'm going to say graphs of the polynomials. Graphs of polys are smooth and continuous. Smooth and continuous. Okay, there we go. Smooth is, da 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 da. And continuous is da 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 da. You can see I never pick up my pen, stylus from the pad, paper, whatever. So and smooth is just no sharp corners. What would be not smooth? Da da da. Yeah, no, that's not gonna work. And continuous would be like da 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 da. So a little bit of music included there, but you can see here I'm not actually touching my pen down the entire time. Here we got really sharp corners. Ow! Ow, that hurts. Okay, so 3 to 11. They have this cool graph that looks like this. They're going to say, is this a polynomial? And you're going to say, yes, because it's smooth and continuous. Okay, what about 3, 2, 1, 3? They have this kind of graph here. Is this a polynomial? And you're going to say, no, because they're not connected. I lifted up my pencil to be able to do the other one, okay? New topic, 3, 2, 15. That's a pretty interesting thing. They want you to match the function with the graph. And what I've done in my notes is simply just give you the answers. Yep. What I'm going to do is I'm going to write out all 4 of these, and then I'm going to draw the pictures, and then we're going to talk about it. So there's 2 of them. Here's another one. Yep, it's squared. And here's the last one. Uh-oh, this one's a big one. Negative x cubed minus x squared plus 4x and then minus 1. All right, cool. Let's do a graph for each one of these. This one looks kind of like this here. Wow. This guy here looks kind of like this here. Oh, yeah. What about this one here? He's been shifted to the right a little bit, so he looks like this here. And then finally, including creepy voice, we got this here. So I'm having too much fun with this. So how do I know which graph goes with which function? How am I supposed to know? Well, a calculator. But besides that, what I'm really going to be looking at for this problem and some others are what we call end behavior. End behavior. End behavior. What is going on at the ends? Notice here, this is falling on the left and falling on the right. This is rising on the left, rising on the right. This one here is falling on the left, but rising on the right. And this one is rising on the left and falling on the right. They're going to use that language. I can't write it every time, but they'll say falls left, falls right. And guess what you do? You click that one because that's the correct answer for that one, I guess. Et cetera, et cetera. So this is a matching one. They're also going to be talking about the falling and rising and all that stuff. But let's do a formula. Let's make a formula for this kind of thing because this is kind of confusing. And I'm going to come back to this and show you how the formula applies. End behavior. Here we go. So, first off, I'm going to give you my proto examples. I got positive x squared. Notice a positive in the front and an even power. Now, when I graph this, it's just a plain old parabola. But you can see the ends here. I'm rising. That one. I'm rising on the left and I'm rising on the right. Rising on the left. Rising on the right. I'm not going to write that every time. This is good enough notation for us. And the reason why this is because it's positive even. Positive means going up. Even means the same direction. They're both going the same direction. Okay, so what if I had a negative x squared? Notice here I got negative in the front, but still an even power. Well, negative means going down, and even means the same direction. Sure enough, this is the end behavior. This is what the graph looks like, and this is the end behavior. So I'm going to fall on the left and fall on the right. Okay, what about a positive x cubed? Notice that we have a positive here in the front, and now we got an odd. Now, odd just means they're going different directions, but positive means that in the end, it will go positive. So let me show you what that means. I'm going to start down low, and whoa, I want to actually do cubic here, a real cubic. I start down low, but eventually it should be positive. That's what that means at the right end, at the right side, as you're going towards infinity, positive infinity this way, of course, you're going to go up. So that's falling on the left and rising on the right. Last one, of course, we got negative x cubed. It's a negative in the front. And we got an odd power. Odd means, again, they're going to go different directions. But in the end, on the far right side, as we keep reading left to right, it should be going down. And so let me actually draw what negative x cubed looks like. It looks kind of like this here. Again, starting off rising, but then in the end, we're going to be falling because we're always going left to right. So rising on the left, falling on the right. Whew. That was a lot. These are the prototype-y kind of examples. And what I'm going to do is go back up now to this problem here, and we're going to see why things work out. Now, to know what power we're looking at, these are technically the degrees. They're the biggest powers. And it's the sign in front of that biggest power. What I like to call them are the boss. The boss. Because the boss has the biggest degree, and they could be positive one day or they could be negative another day, let's say. I don't know, just making something up there. But the biggest degree, and so which one here has the biggest power, the biggest degree? It's this guy right there. That's our boss. This is our boss. Boss! So notice that he's negative, But he's also even, so he's going the same direction. So same direction, negative means going down. Okay, what about this guy? How do I know this one here? Well, if you FOIL this one out, it's x squared minus 8x plus 16, something kind of like that. But notice here, positive, even, he's my boss. And so positive means going up, even means the same direction. Out of these two, you can see this one here, positive. This is the biggest one, so that's my boss. And so he's positive. He's going to be going up in the end, right? But odd means that we're going in different directions. Last one, you can see this one's the biggest power, the biggest degree. Boss. And so we got a negative, means eventually I'm going to be going down. But they're going to be opposite in direction. Okay, that was a multiple choice, and that was a long time to talk about that. So scroll. Let's do some more, and this will be more, shorter versions of the same idea. So I got f of x is equal to 6x to the 7th minus 8x to the 6th. Plus 8x cubed plus 8. And they're saying, what's the end behavior? Now, they got a lot of English. Rise left, fall right, blah, 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 all that kind of stuff. I'll just use my arrows like I normally do. First off, I need to know who's my boss. Boss! Because he's got the biggest degree, the biggest power, and he's also, well, that's it. That's the reason why I chose him. But he's a positive in this particular case, and he's got an odd power. So going in different directions, eventually going to go positive in the end. So we're going to fall to start with the left, but eventually we're going to rise on the right. Again, reading left to right there. Boss. Biggest power, biggest degree. Don't bosses have the most power? That was a good way to say it. Bosses have the most power. Ha 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 ha. I'm just making stuff up here. Okay, new topic. So we got f of x is equal to 6x minus 8 and then x minus 9 all squared. And they're wanting a few things. For part A, they're saying find the zeros. So like x equals what? And so what they mean by zeros is they're setting this whole thing equal to 0 and solving for x. This is actually super easy, and I believe we've done this before. So this is x equals 8, and this is x equals 9. So you're going to put an 8, 9. Yay! That's all it is. Okay, so cool. That was good. Part B is asking for something new. They're wanting the multiplicity. Find the multiplicity. Okay, now what does that mean? It's how often a 0 occurs. How often a 0 occurs. And I often just say, look at the power. Look at the power. And so I'm looking here at this, let me use a different color. Looking at this factor. What's the power? It's a 1. So he has a multiplicity of 1. He happened one time. But I'm looking at this one right here. What's his power? How many times did he happen? Like, if I were to write it out, wouldn't I have 2 of them? So I would have like 9 and 9 or something like that. The idea is that you don't have to keep on saying it over and over again. You just say, he has a multiplicity of 2. So this is where my math lab gets really weird. For the value of x equals 8, we have a multiplicity of 1. That's your answer, kinda. And then x equals 9, it has a multiplicity of 2. Again, that's your answer, kinda. I'm going to say that this is probably one of the worst ways for my math lab to ask you what they want. They use so many words, and they're confusing words. They're like find the multiplicity of the smallest 0 and that kind of stuff and whatever. So this is the smaller of the 2 zeros, or the more negative, perhaps. I don't know. And then this is the larger of the 2 zeros, and this is the more positive, greater one than that. And so they're going to not ask for that value, but they're going to ask for the multiplicity of that value. Part C. So just put them in, figure it out. I know it's rough. Part C is going to say, well, where does it cross the x-axis? Where does it cross the x-axis, and where does it touch the x-axis? Now, when we found our zeros, these are also x-intercepts. This is where you're going to be crossing or touching the x-axis. X-intercepts. So we're saying, hey, we have our answers. It's the 8 and a 9, but where are they going to cross and where are they going to touch? Crossing occurs when you have an odd multiplicity. And touching is when you have an even multiplicity. Okay, so how does that work? Let's go back, and I got x is equal to 8. It has a multiplicity of 1. This number is odd. Therefore, we're going to cross at that point x equals 8. Okay? X equals 9. It has a multiplicity of 2. This number, 2, that's even. And so therefore, we're going to touch at x equals 9. Again, we're touching and we're crossing at that value. So I'm going to do a graph. Now, they're not going to require a graph, but I'm going to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my 8 and there's my 9. And end behavior, which is also something to talk about here for a second. The end behavior, again, I'm looking for the biggest degree, the boss. Well, I would have to FOIL this thing out. Okay, I'm going to let you all FOIL it. Here we go. Dun, 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 dun. No, it would take forever. So instead, what I want to do is find all the leading terms. I'm going to multiply them together. 6, positive 6 technically, right? Positive 6. I got x to the 1, and I got this x squared. If you take all these together and say you're going to FOIL it, I mean, that's what you're really going to do. You're going to FOIL, expand this thing out, right? Expand. And what you're going to get is a positive 6x cubed plus dot. Takes forever. I don't even care about everything else. I only want to know who's the boss. Boss. He's the boss. He's got the biggest power. Everything else is going to be less than a 3 degree. So, he's got the most power. So, again, I'm only looking here. What has he got? Positive in the front. Odd power. Positive odd. And so we're going to go in different directions, but eventually we're going to go positively. So in a way, I'm saying for my graph, we're going to be starting low and then we're going to end high. Odd, different directions. Eventually, though, we're going to go positively. Okay? Cool. Well, I just told you that at x equals 8, I'm going to cross. I'm going to cross right on through this thing. Now, I already messed up a little bit. Let me make this look a little bit better. So, I mean, it actually looks better. Something about right there, let's say. Okay, cool. Same thing. So at 8, I'm just going to cross right on through. This is a river. I'm going to cross the river. Here we go. Cross right on through. There we go. But then over here at 9, I'm supposed to go and touch. Just barely touch the water. And I come back and I touch. Bloop. And it's like, oh, that's so cold. And then I just run away. This is not the best looking graph, but it's the idea that... that's what it looks like. It's gonna do this, and it's gonna be touching, crossing right there, touching right there. End behavior. Cool. We just did that, and you didn't have to do all that, but I wanted to show it, so there we are. 3, 2, 3, 2, 27. F of x. We're gonna do a lot more of that, obviously. F of x is equal to negative 4 times x minus 9 times x plus 1 cubed. And they want pretty much the same thing. I'm going to go and graph it, but let's go through this much quicker because we know what's going on. Right here, I got x equals 9. Multiplicity of 1. This number is odd. This number right here, this 1, that's an odd number. And therefore, we're going to cross the x-axis there. Right here, solve for x. I get a negative 1. Multiplicity of, what do we got? 3. See? But this number right here, this is an odd number. And so therefore we're going to cross there as well. And that's it. So this is your answer. You put it in the correct format, A, B, and C for MyMathLab. Takes forever, but that's definitely the point here. A, you're going to put these numbers in right here. B, you're going to put those numbers in right there. And C, under the cross label, well, they both cross. So you'll just say they all cross. I think you just click a button there. Okay, moving on. The graph of this is pretty interesting. So we got at -1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. They're both crossing. What is the end behavior? What does my boss look like? When I start foiling this thing out, what do I get? Well, I got a -4, x to the 1, and an x cubed. If you put all these together, you get -4 x to the 4th. Now notice, even power. And so they're going to go the same direction. Negative means they're both going down. Why does my notes have a 1 going up? I don't know. My notes are wrong. Where's a pencil so I can change this thing? So, honestly, I know I'm recording, but I mean, I'm really picky about making it right. But this pencil has no lead. It's going down. Down. Good enough. Let's graph this thing. So going down, going down, and I'm going to cross through each one of these. So this is where it gets a little weird because here, multiplicity 3, MyMathLab's not going to talk about it, but hey, you know what? You're going on the calculus, aren't you? At least the pre-cal. So the idea is that when you have higher multiplicities, you're going to have like a flat zone for a little bit. So this is going to just cross right on through, whoosh. But this one's going to linger for a little bit, and then whoosh. So watch out for that. Here we go. I'm going to go here, and I'm going to linger for a little bit, and then I'm going to come up. It's only crossing through, but it's just kind of lingering a little bit. We're going to come up, and we're like, oh, right there, we need to cross through it. Here we go, here we go, here we go. Right on through. That is my graph. Definitely not the best graph. If I was trying to make it better, it would look something closer to this, maybe. Wait, hold on. Yeah, it probably looks something better like that. But the idea, though, there you go. And also the idea is you didn't have to do that. But it was good. It was good that we did it. So here we go. 3 to 29. Did we already do this? No, we didn't. Oh, look at this. I understand now. So I've been talking about this, and I might not have been correct about my speaking it weirdly for the past few problems. Regardless, it's going to happen here for sure. Yeah, small is 0, large is 0, positive, negative. Yeah, exactly. Okay. You know what's funny about MyMathLab and this particular randomization? They actually keep the 1. I don't know why. It's a mystery. So they all have an x. I'm going to factor an x out. X squared minus 2x plus 1. And I wonder, could I factor this? What two numbers multiply to make a 1 but add up to -2 instead of be a -1, -1? And if I were to simplify this, that would be a squared. So this is what we're actually working with. Set it equal to 0 and start solving for x. Yes. I'm just looking at the next problem, and it was very, very, very similar. So, okay, cool. When you have a solve for x here, of course, it's going to be a 1. Multiplicity of 2. You can see that power right there. This number is even, and therefore we're going to touch the x-axis there. What about this guy? Solve for x. So what do you do? Solve for x. Well, there's not a number, so I say, well, it's not a number, and I put a 0. But regardless, the answer is 0. If it's x by itself, it's a 0. And so how many times did that happen? 1. 1 time. That number is odd. This number right here, that's an odd number. And so therefore, we're going to cross at that point. That's your answer, but again, I want to go a step further. I did not do this on my paper, so hopefully I don't mess up. I got one here at 0, and I got another one here at 1. Here at 0, I'm supposed to cross, but over here, I'm supposed to touch. I want to know what's the end behavior. I can't really know what's going on until I do that. Oh, right here. Boss! He's the biggest power, biggest degree. Positive odd, so falls left, rise right. falls left, rise right, and I'm going to cross right on through, whoosh, and I'm going to touch this, bleep, and there you go. There's my graph. Cool. Next one, 3, 2, 47. I got f of x is equal to x to the 4th minus 4x cubed plus 4x squared. What do they all have in common? X squared. Leaving behind an x squared minus 4x minus 4. Can I factor that? Yes. It's minus 2 and squared. Now, I skipped a couple steps there, but 2 and 2 make a 4. 2 and 2 make a 4. Multiply and add. And I know I have both the same 2's, so there we go. Actually, I wrote something down wrong. Hold on. Positive, negative, positive. Positive, negative, positive. Okay, now it's correct. Everything's fine now. Watch out. I didn't know math. Okay, so we got here x equals 0. Multiplicity of 2. That number, this number, that is an even number. And therefore, we're going to touch. Okay, x equals 2, obviously. Multiplicity of 2 this time. You can see right there, same thing. This number is even, and therefore, we're going to touch. So we're touching twice at those 2 different points. This is your answer, but I'm going to go a step further. End behavior. Let's do one last end behavior. Right here, positive, even. Positive, even. And so end behavior is going to rise on the left and rise on the right. Again, positive means up, even means the same direction. So there we go. Let's graph this thing. At 0, at 2, and they're both touching, and we're supposed to be rising on the left and rising on the right. Here we go. Touch, blip. Touch, blip. And there we go. Ta-da! We made a cool polynomial. It's a W. So, next question. In fact, wow, we're really rocking and rolling here. That's awesome. So this is the last question. There's a lot of words. Dun, dun, dun. 3, 2, 73. We got, well, we got a lot of words. Let's just talk about it. We got a lot of words here. And I don't know what they're wanting to get at with all these words. There's so many words on this problem. If you're pulling up the homework and kind of looking at it right there, there's a lot of words. But what they have is a little box with a chart. The chart box, the chart button. Click that. Click it. And you should get, well, a lot of numbers now. And if you, like, it's a big old box and it's got all this stuff, and it's got all this stuff. And then if you scroll down to the bottom corner down here, there's actually something very, very important in the bottom right corner. F of x is equal to 0.75x cubed minus 23x squared minus 884x and then 37750. Okay. They also say that x is years after 1970. I think this is the tiger problem. Something about tigers and extinction or something. I don't know. So they're saying, hey, we need to look at the year 2010. So I'm going from 1970 all the way to 2010. How much x do we got? 40. Good. So then I'm going to take that x equals 40, and plug it in to this really big formula. Okay. You just got to breathe while doing it because it's just so much. But guess what? We're going to use a calculator, and that's okay because we're just using scientific calculator here. And I got 13590. Now, I can't remember if I rounded on that. I'm just copying my notes here. But there we go. We got something really nice. I guess that's the amount of tigers or something. That's part A. And then after that, part B, they're saying, hey, write the ordered pair for this. And so what you're actually wanting to do in the box is use a set of parentheses, 40, 13590, just like that, an XY coordinate point. That's what they're trying to do. Part C, we need to look back at the chart, and back at the chart, we've got bars. bars, 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 bars. And this one here is 13600 at the year 2010. And they're wanting to compare my answer with their answer. Well, notice that mine was 13590. Theirs is 13600. And so mine is 10 less, and I would say like underestimated. So it's going to say underestimate by 10. These are your answers. You just kind of click it however you need to do, okay? That's all I got. That's it. If you have any questions, let me know. Thank you very much. Have a great day.